Hi, my name is Brad Duncan, and I'm a threat intelligence analyst with Palo Alto Networks, Unit 42. And this is the third video of the Palo Alto Networks Unit 42 Wireshark workshop. If you're watching this video, you should already have seen our first and second videos of this workshop series. In our previous video, we discussed how to set up Wireshark for the rest of this workshop series. As a reminder, the packet captures and PDF files of the slides used for these videos are available on our GitHub page at github.com/pan-unit42/Wireshark-workshop, and these are all stored as password protected zip archives, and the password is Unit 42. Here's our overview. First, we'll look at host information. Then, we'll look at operating system and web browser. Next, we'll determine the Windows user account name in Berberos traffic from an Active Directory environment, and then other options to find a Windows host name. Here we have the Xubuntu desktop environment that I'd set up in the previous two Wireshark workshop videos. Going to the GitHub page, going to download the PCAPs. Password, as I'd said before, is Unit 42. And here are our PCAPs. Let's open up the first one. I'll use my basic filter, and here we're looking at web traffic. Now, if we were to look at the source IP, we would see that the source IP for this web traffic is all the same IP address. And that IP address is associated with a specific MAC address. This MAC address is the first 3 bytes that show a vendor ID of Apple. So this indicates this is possibly an Apple product like a MacBook or an iPhone or an iPad. Keep in mind that MAC addresses can be changed using various methods. For example, here I have the properties of an Intel Network Interface card, otherwise known as a NIC, and I can go into the adapter properties and I can change the MAC address. If I did nothing, if I didn't change the MAC address, traffic to and from this NIC would show a MAC address with an Intel vendor ID. But if I change it to a MAC address with a Cisco vendor ID, I could be trying to fool people into thinking traffic to and from this Windows 10 host might instead be traffic to and from a Cisco router. Now, generally, most people do not change their MAC addresses. So for this Wireshark workshop, we can assume that the MAC addresses have not been changed or altered unless we have evidence that shows otherwise. Getting back to our PCAP, let's clear our basic web filter, and now let's filter on DHCP. I'm going to hide the host column, so we don't need to see that for DHCP traffic. Now, DHCP is how a host's network hardware gets an IP address. As you can see here, the IP address used by the MAC address is 0000 when it initially sends a DHCP request, so it can be assigned an IP address. The DHCP server, in this case 10.5.3.1, issues that MAC address an IP of 10.5.3.177. And we can review the frame details of the first frame in our column display. This shows the DHCP request. Expand the line that says Dynamic Host Configuration Protocol Request and scroll down. Scroll down to the end. we can see the requested IP address of 10.5.3.177. Let's go ahead and expand that hostname line, option 12 hostname. We scroll down and we can see a hostname of Greg-MacBook Pro. Now this hostname is another indicator that we're looking at traffic from Apple hardware as indicated by the MAC address. This is how we can find a hostname through DHCP traffic. But if you have access to full packet capture in a work environment, you probably won't run into DHCP traffic when investigating suspicious network activity. But if you do, this is one method of finding a hostname. Now, let's filter on NBNS. NBNS stands for NetBIOS Name Server. NetBIOS is a protocol developed by Microsoft. In addition to Windows hosts, we can also find NBNS traffic generated by Apple hosts running Mac OS like MacBooks or desktop Macs. And make sure you're looking at the first few frames in the column display. This is NBNS traffic from 10.5.3.177 broadcasting to the entire 10.5.3 LAN segment. 10.5.3.255, as we see in the destination column here, is the broadcast address for that LAN segment. In those first three frames, the info column shows registration NB Greg-MacBook Pro, which is the same hostname we found in the DHCP traffic. If you have NBNS traffic in a PCAP, you can often correlate the MAC address with the IP address and the hostname like shown here. As I already mentioned, NBNS traffic is generated by Windows hosts and MacBooks or Macs. So NBNS traffic can be a very easy way to find the hostname for these types of hosts. In this section, we look for operating system and web browser information in unencrypted HTTP request headers. But keep in mind that malware often spoofs user agent lines that we use to identify the OS and the browser. Some web browser plugins or extensions are also able to change these user agent lines. However, the examples in this workshop video are not altered, and they were caused by actual web browsers. We are still using our first PCAP for this workshop video, so if you already closed it, open it again. Let's use our basic web filter. Hide our source IP address, hide our source port, and show our host column. Look for the first HTTP request to www.kansastravel.org and follow the TCP stream. After you follow the TCP stream, find the user agent line in the HTTP GET request headers, which is right here. This traffic was caused by using the Safari web browser on a MacBook. You can see Safari listed in the user agent line. You can also see Macintosh, Intel, Mac OS X 10.15.7. Mac OS used to be called OS X, but it changed its name to Mac OS in 2016. However, recent versions of Mac OS still show up as OS X in user agent lines from web traffic. 10.15.7 is used for Mac OS Catalina, which is a relatively recent version of Mac OS, and it is still supported by Apple. Let's open our second PCAP for the workshop. We're going to use our basic web filter and scroll down until we find the first HTTP request to www.professorsbookshelf.com. When you open this PCAP, you can review the DHCP and NBNS traffic for the host identification like we did before in our first PCAP. But for now, we're focusing on identifying the OS in the web browser. Basic web filter. First HTTP request to professorsbookshelf.com. Follow TCP stream. And here is the user agent line. As we review this, note where the user agent line shows Windows NT 10.0, which is used for Windows 10 hosts. Near the end of the user agent line, we see EDG, which is for the Microsoft Edge web browser. Like we saw with OS X and Mac OS in our previous example, Windows NT is an old name which is still used to identify the type of Windows operating system in a user agent line. Here is a list that shows, for example, Windows NT 5.1 represents Windows XP, NT 6.0 represents Windows Vista, and so on. For Windows-based traffic in this Wireshark workshop, we will be using Windows 10 as much as possible. On rare occasions, I might use Windows 7 when a malware sample or an exploit requires an outdated version of Windows. For Microsoft's newer Chromium-based web browser, you should see Edge without the E in the user agent string. If it's Edge with an E, that means it's the older version of Microsoft Edge before it switched to using Google's Chromium code base. Both Microsoft Edge and Google Chrome identify other web browsers in the user agent string, like Safari. I understand this is done for compatibility reasons, since some websites are optimized for certain browsers. Whatever the reason, we still see these additional strings in Edge in Chrome. Now let's open our third PCAP for this workshop video. Again, like our previous two examples, we have DHCP and NBNS traffic that you can review to get the host name. But for now, we're looking to identify the operating system. This is traffic from a Windows host, and we need to identify the version of Windows it is running. So use the basic web filter, find the first HTTP request to historyarch.com, follow the TCP stream, and let's figure out which version of Windows this is. Basic web filter. First request to historyarch.com, follow TCP stream. And here's the user agent line. This user agent string shows Windows NT 6.1, which is used for Windows 7. We also see x64 and Win64, which indicates this is a 64-bit version of the OS, not 32-bit. The web browser in this example is Google Chrome. And similar to the newer Microsoft Edge browser, Chrome contains strings for Safari, Apple, and Mozilla. Now let's open our fourth PCAP. In this PCAP, we have DHCP traffic, but there is no NBNS traffic. We can look at the frame details for our very first frame, which is the DHCP request. Let's enlarge the frame details here. We can see that the Ethernet address shows a vendor ID of LG Electr, which means LG Electronics. Let's find the host name in the frame details. I'm going to expand this line, scroll down, find the option for the host name, and look for the host name. The host name here shows a string that starts with the word Android, so this might be an Android device like a phone or a tablet. We will now use our basic web filter to find the first HTTP request to a host name that starts with Miniature. I cannot properly pronounce that full host name. We'll do that and review the user agent string. So here I do the web filter. I'm going to scroll down a bit, and here we go. Follow TCP string. And here is the user agent string. This is an Android host using Chrome as its browser. Android hosts include a model name or a model number in the user agent line. In this case, we see LM-X210APM. Search for that model number. Here, I used the Google search engine, and you should find that this model is an LG Phoenix prepaid phone that uses AT&T as its carrier. Now, on to our fifth PCAP. For this PCAP, Wireshark, at least the Wireshark version I have here, does not show a vendor ID for the MAC address. And even though we have DHCP traffic, the DHCP request does not contain the hostname option. So I cannot find the hostname in this DHCP traffic. If we use our basic web filter, here in the beginning, we see lots of traffic to Google-related domains. So with our basic web filter, let's scroll down to find the first HTTP request to nelson-haha.api-meal.eu. Just scroll down to the end here. Here's the first request. Follow TCP stream, and the user agent string is right here. In this case, we see Android 11 and a model number, Pixel 4a 5G. This is a Pixel 4a 5G smartphone running Android 11, and it is using Chrome as its browser. We are ready for our sixth PCAP now. Again, in this PCAP, Wireshark, again, the Wireshark I have here, does not show the vendor ID for the MAC address. There is no NBNS traffic here, but the first frame is a DHCP request. And we can find the host name used in this DHCP request. Here we go, option 12, host name. It shows a host name of home iPhone. If we use our basic web filter, the first three frames in our column display show traffic to apple.com domains. We will now follow the TCP stream for the first HTTP request to www.culturewest.org. So we can determine if this is an iPhone as indicated by the host name in the DHCP request. Here's the first request to culturewest.org. Follow TCP stream. And the user agent string is right here. Here we see iPhone in the user agent string, and we also see the version of iOS or iPhone OS that this phone is running. And I used Safari as the web browser when I generated this traffic. Let's now open our 7th PCAP. Again, in this PCAP, Wireshark is not telling me the vendor ID of the MAC address. However, the first frame is a DHCP request, and we can find the host name in the frame details as we've done before. So we're on our first frame, DHCP request. I expand the dynamic host configuration protocol line. Scroll down to the very bottom. And the host name reads Connors-iPad. Using our basic web filter, again, the first 3 frames in our column display show traffic to apple.com domains. We will now follow the TCP stream for the first HTTP request to www.watson.org so we can determine if this is indeed an iPad as indicated by the host name in the DHCP request. Here we are, first request to watson.org, follow TCP stream. The user agent string is nearly identical to our previous example with traffic from an iPhone. Instead of iPhone, we see iPad. And again, I used Safari as the web browser when I generated this traffic. We are now done with examples of mobile devices as we move on to our 8th PCAP. In this PCAP, we'll follow the TCP stream for the first HTTP request to www.environmentlaw.org.uk. This is an example of a desktop running Linux. We can see this is a 64-bit version of Linux, but we don't know what distro this is. I generated this traffic using the Knoppix Linux distro, and I used Conqueror as the web browser. Unlike Knoppix, some Linux distros announce themselves in the user agent line, and that's what we have for our 9th PCAP. Open our 9th PCAP in Wireshark and follow the TCP stream for the first HTTP request to www.worldmatetravel.com. This is an example of Ubuntu Linux. We can see Ubuntu in the user agent string, and this traffic was generated using the Firefox web browser. Our final PCAP for this workshop video, the 10th PCAP, is traffic from a Windows 10 client logging into an Active Directory environment run by Windows Server 2019. This is the same type of traffic you might see in an enterprise environment when someone logs into their Windows computer. The domain used for this example is studiosolutions.info. The domain controller is at 172.16.1.2, and the Windows client is at 172.16.1.121. Let's open the 10th PCAP. And we will filter on Berberos.cname string as shown here. The results will have TCP segments from Berberos traffic that reveal the host name, and they also reveal the Windows user account name. Select the first frame in the column display, and we will expand our way to the CNAME string value and apply that as a column. First, we expand the Berberos line. Underneath that, expand the line titled AS-REQ. And underneath that, expand REQ-body. Under REQ-body, find and expand CNAME. And then, underneath that, expand CNAME string. Find the CNAME string line with the value, which in this case should be desktop-C2Y6U4A $. Left click on that to select it, and right click to bring up the menu. Then click on Apply as Column. So we're back here in our PCAP. Make sure I've got the first frame selected. I'm going to expand the Berberos line. Underneath that, expand AS-REQ. Underneath that, expand REQ-body. Then I have to scroll down a little bit, find CNAME, and underneath CNAME, find CNAME string. Here is our CNAME string value. Left click on it to select, right click to bring up a menu, and then Apply as Column. We now have a new column in our column display with the heading CNAME string. Scroll down to the end and you should see the Windows user account name in the last few frames of the results. This name should be Rakesh.Modi. This PCAP consists of Rakesh logging into a Windows 10 host in an Active Directory environment, then viewing a web page from redhill.net.au in the Google Chrome web browser. If we were to filter on our basic web filter, we can find that traffic. Now, I only use CNAME string, this column, whenever I'm trying to determine a Windows user account name. So I generally hide that column when I establish it, since I only use it on rare occasions. Now, if you filter on Berberos CNAME string, you'll see the traffic, and all you have to do is show the CNAME string column. Sometimes when investigating suspicious traffic, we cannot find the hostname in DHCP, NBNS, or Berberos traffic. If that happens, you might find the hostname for a Windows host in SMB traffic. First, filter on SMB, and you should find a host announcement as shown here. And here we see what we just saw on the slide. If you have no SMB traffic and the client is a Windows 10 host, try searching for the string desktop- in UDP traffic. That should give you the results shown here. Now, it's case sensitive, this string that we're searching for. And we can see within the first 4 or 5 frames, we have now finished part 3 of the Palo Alto Networks Unit 42 Wireshark workshop. In this video, we covered host information, operating system and web browser, finding the Windows user account name in Berberos traffic, and 2 other options to find a Windows hostname. Thank you for watching. Our next workshop video will be part 4, non-malicious activity.